All right, hey folks, we are going to do our first, how would you call it, online lesson of the year. So going to make this as quick and painless as possible. All right, so here's what I want to do. I want to go over a couple of the problems from yesterday just to make sure you understood what you were to have done. Especially those last two were more complicated than the other problems here. And then I'm going to introduce what you're going to do for me for today. It's very similar to what you did on Friday, and hopefully with some extra practice you're going to be a little bit better at it, and then we can kind of take a look at that on Tuesday when you come back to school. So let's get after here. Let's take a look at those last two problems from let's see here. Oh, hold on. Let's try something different. I don't know if this will work. Try again. There we go. Start the activity. So as I look at the fourth proof that you guys did, this one was harder because nothing is filled out. And so I'm going to start with the given here. And it doesn't matter if you put this one first or this one first. Okay, the fact is that we need to make sure that we have our given set up first so that we can use things from the given to build our argument for why something is what it is. So as you look, I'm filling in the given right now. Okay, and we're told that angles 1 and 2, they add up to 180. Hey, they're a straight line, they're a linear pair. Makes sense. 2 and 3, same thing, straight line, linear pair. They're going to have a sum of 180 as well. Okay. Now, being that both of these equal 180, that means that these two angles have to equal these two angles because their sum is the same. So I'm going to go ahead and say, hey, I'm going to take this 180 out and I'm going to put this in its place. And what's that called? That's going to be our substitution property. Okay, so I'm substituting that in it as my new equation. Now, if I have this equation, I can then subtract angle 2 from both sides, and what's left over is my proof. Okay. Now, every year I get the question, or people want to write in the very last step is the prove because the first step is the given, and that's what we have up here, given and prove, and that's not the case. Every step after the given is going to have a reason that relates it to the previous step. So what did we do here to go from here to here is what we put down here. And since we subtracted angle 2 from both sides, I'm going to go ahead and put in the subtraction property of equality there. Okay? All right, now, this last one, if you were able to get this and be able to think through this whole process, is quite a tribute to you because you haven't been practicing proofs for very long. And yeah, this one was a doozy. So let me go check something here. Yep. So if I go ahead and put down my given as my starting point, okay, and let's see where it's at. There it is. Okay. So we know, and if I could mark this, I would, that AE and BD, so the whole length here and the whole length here, they are congruent. Okay. We also know that CD and CE are congruent. So on my paper, if I would have drawn this out, I would have marked this segment congruent to this segment. Okay. Now they're telling us that AE, this segment here, is made up of AC plus CE. That makes sense. This little one plus this little one equals the whole. Okay. What is that called? We're going to call that the segment addition postulate. If we have segment plus segment equals the whole segment. Okay. Now from there, let's see here, BD, I'm going to put BD equals AC plus CD. Now the reason why I'm doing that, you notice here in the first one that these two were equal. And so I can take out this one and put this one in its place. All right, I can also take out CE and put CD in its place. Okay, so I'm taking those out. Now, when you take something out and replace something of equal value, what are we doing? We are substituting. Okay, we're using the substitution property. Okay. Now, from there, let's see here. I am going to go ahead and put this down here. What just happened here? Well, I took this side and put it on the other side, and I took this side and put it on the other side. What's that called when we switch sides? This is called the symmetric property. Symmetry, to be the same on both sides, so I can rewrite it, is the symmetric property. Now again, you don't see the symmetric property very often in the proofs as we move forward, okay? But just be aware, if A equals B, then B equals A. Now, the next part says the segment addition postulate. All right, so as I look over here, this is the only one that would have anything to do with the segment addition postulate. So let's see if it makes sense. BD, the entire segment, is made up of BC and CD. So yeah, that works there. That is the segment addition postulate, okay? Now, from here, I'll just do this. I know this has to be my last step. That is my proof. So I'm going to put that in right there, which means this will be my next step. Now, how did I get this from all this above? Well, we knew that BD is equal to AC plus CD, okay? But we also know that BD is equal to BC plus CD. And so if you look here, they're using the transitive property. If A, this part right here, if A equals B and B equals C, then A equals C, okay? So again, A equals C. That is the transitive property, okay? Now, looking at both sides of my equation, I've got a CD on both sides. So what can I do to both sides? I'm going to subtract CD from both sides, and I get this as my final statement there. Okay? So again, I know that was a lot to think about. Bring this back up here. Come on now. There we go. I know that was a lot to think about. There's a lot of steps there. And when we get into proofs, we're going to start with small proofs. You know, could be as small as 3 steps. And we'll build up from there to be as many as 8, 10, 12 steps, okay? But we're not going to jump to there right away, all right? My hope is as I went through that you can see how everything is supposed to piece together. I hope it made sense, even if you weren't able to think it through on your own yet, which is fine, okay? Now, to finish things off, Matt, if you have yours, I'll take it here. Your homework is coming from Schoology, and so I've got Matty Youngie's computer here, and I'm going to try to use my document camera, so give me 1 second here. Oh, there's Matty in the background. So, all right, so we've got her pulled up onto Schoology. I'm going to try to zoom in here a little more. Man, that's awful blurry. I apologize about that. Actually, you know what? I think I can fix it. Give me a second here. Is it that button? Nope, not that button. I thought it was. There you go. I guess that's about as clean as it's going to get. So, anyways, if you look off to the right side, she's in her geometry portion of Schoology. If you click on the 2-4 proof Google slide, that is the assignment for today. So I'm clicking on that, and it's coming up, and I think I'm going to go over to document. Is that right, Maddie? Document. Yeah, I'm going to let this load for a moment. Okay. And what you're going to see is I have actually created a Google slide for you, and you are going to edit the Google slide here. So I'm going to go ahead and click on that, and it's going to come up for you. Now, just like you did your homework on Friday, this is going to be a click and drag proof activity. So as you look, let's go here to the first one, okay? Everything's laid out for you right here. You've got all these statements here on the left-hand side, and on the right-hand side, you can click and drag. So if I click on division property of equality, I can go ahead and drag that over here. I'm going to put it right back so I don't confuse Maddie later on. But you can click and drag and put it next to the statement that you believe is the correct placement for that reason. All right. Now, as you continue to advance through these proofs, okay, you'll notice here I gave some statements and some reasons. Now, here's the deal. There's an open spot here on the reason. Hopefully no one gets that wrong. Hint, hint, it's the given. Then you have a statement here that needs filled in, a reason here, and then 2 more statements down here, okay? Hopefully you can start to see how this process is put together. And it looks like we have a third. Now, in this third one, I've mixed everything up, okay? I have mixed everything up, and you have to figure out from beginning to end. I'll even help you out on this. Your given is the piece of information right here that basically outlines everything that you see in the picture, okay? And your last step is going to be this one right here, okay? That will be your last step, the y equals 6. So you have to go from the beginning to the end on this proof right here. Now, one thing to think about, do not click on the edges or the corners of these boxes here because they will expand and contract on you and it can throw you off. Make sure that you are clicking in the middle of the box, and then you can easily just click and drag the boxes into the correct position, okay? So there's number 4. It's set up in the same way. I think on the previous one, all of these statements were out of order on this side, and the reasons were out of order on this side. When you go to slide number 5, these are switched, okay? I have statements and reasons on this side, statements and reasons on this side. So see if you can figure those out. And I think that's it there. You have 4 different proofs. I believe that's the last one. Yeah, looks like it. 4 different proofs to fill out for me. Okay. So, anyways, again, I hope this is going to help you improve your ability to work through these proofs. And if you have other questions, come back and talk to me on Tuesday. Otherwise, good luck.